You know, deep down in the basement of every skyscraper, every hospital, every mall, there's a beast just sleeping. It's a silent guardian waiting for a call to action that it really hopes never comes. Well, today, we're not just going to learn about it, we're going to wake it up. So, here's how we're going to do this. First, we'll meet this unsung hero. Then, we'll get into the secrets of its rock-solid foundation, check out the brains that bring it to life, and see the intense training it goes through. And finally, we'll look at what happens when even this guardian needs a little help. All right, first up, the unsung hero of safety. Look, in firefighting, all the glory goes to the brave people on the front lines, and for good reason. But in a high-rise fire, the whole battle can be won or lost before a single firefighter even gets there, all thanks to a machine that most of us will never, ever lay eyes on. So think about it. When you picture a fire, what do you see? Hoses, big red trucks, firefighters, right? But what if I told you that inside a big building, the most important first responder is actually a machine, just hidden away in the basement? Any ideas? Yup, it's the fire pump. And listen, this isn't some pump you'd find at the hardware store. This thing is a behemoth. It's a centrifugal powerhouse that is literally the beating heart of the building's entire sprinkler system. See, sprinklers are the first line of defense, but they're totally useless without one crucial thing, a massive amount of water, delivered at incredible pressure. And that is the fire pump's one and only job, to unleash that flood, instantly and without a single doubt. So how do you even install a machine this important? It's not like you just bolt it to the floor and call it a day. This is section 2, building a solid foundation. And this is where a single millimeter can be the difference between life and death. The scale we are talking about here is just mind-boggling. The installation manual requires a concrete foundation that weighs at least 2.5 times more than the entire pump setup itself. So why so huge? Because when this machine kicks into gear, it needs a base that can absorb every single vibration, every jolt, and every shock without moving an inch. It has to be immovable. And the process itself is a masterclass in precision. First, you pour that massive concrete foundation, and it has to be perfectly level. Then, you mount the pump using these tiny little pieces of metal called shims to get it absolutely flawless, because even a tiny tilt can cause big problems down the road. After that comes the really critical step, alignment. This is where the motor and the pump are joined together with almost surgical precision. And finally, the pipes are connected in a way that puts zero stress on the pump. Every single step is a vital link in a chain of survival. And these numbers, they really tell the story. The radial alignment, that's how centered the two spinning shafts are, has to be off by less than 0.4 of a millimeter. We're talking about the thickness of maybe 4 sheets of paper. That's it. Any more than that, and the incredible forces at play could literally rip the machine apart at the one moment it's needed the most. Okay, so the pump is installed with the precision of a Swiss watch. But how does it know when to spring into action? Well, that brings us to section 3, the heart of the system. This is where we see how our silent guardian knows exactly when it's time to roar. The best way to think about this system is like a living thing. It's got a brain, a special controller that's always monitoring the water pressure. For diesel models, it has lungs, a heat exchanger that keeps the engine from overheating. It's got a backup heart, too, 2 separate battery units, because not starting is just not an option. And it has arteries, the pipes, which are installed so carefully to make sure no air pockets get in and cause the pump to have a fatal heart attack. Now this table, this is where the genius is. It's a pressure cascade. Okay, so a small jockey pump handles little pressure drops, like a tiny leak somewhere. But what if a sprinkler head actually bursts? Well, the pressure plummets by 10 psi. The jockey pump can't keep up, so the pressure drops another 10 psi, and bam! That's the trigger. The main fire pump just explodes into action. And here's the most important part, that last line. Fire pumps can only be stopped manually. They are designed to run until a human being physically turns them off. That way, they never quit in the middle of a fire. You know, an emergency system that doesn't work is actually worse than having no system at all. And that's why a fire pump's life is just constant training. So welcome to section 4, a strict weekly regimen. This isn't about fixing broken things. It's about making sure they never, ever fail in the first place. This pump lives by a strict schedule. Every single week, it gets put through its paces. Inspections, test runs, the whole shebang. Every month, its electrical systems get a workout. Quarterly, the fuel lines are cleaned. And once a year, the entire system is taken apart and recalibrated. This isn't just a machine. It's a finely tuned athlete, and it's always ready for game day. So what does that weekly training actually look like? Well, for a diesel pump, the engine runs for a full 30 minutes. That gets it up to operating temperature and burns off any moisture that could cause problems. A technician goes through a super detailed checklist, checking fuel levels, making sure cooling water is flowing, listening for any weird noises or vibrations. It's a complete physical, every 7 days, no exceptions. But what if one of those weekly checks does turn up a problem? That brings us to our final section, when things go wrong. And what we're about to see is that almost every single potential issue circles right back to those two golden rules: perfect installation and relentless maintenance. This troubleshooting chart right from the manual is so revealing. Hear an abnormal noise? The number one suspect is misalignment, a direct failure of that precision install we talked about. Or it could be cavitation, which happens when the pump isn't getting enough water. Is the motor overloaded? Maybe a packing gland is too tight. See? These aren't random failures. They're symptoms, and they have clear, preventable causes that are almost always rooted in how much care the machine was given. And this is a direct quote from the warranty policy, and it's basically a mic drop. The warranty is void if they find sand, mud, or construction junk in the system. The manufacturer is saying, look, we built you a perfect machine. It's a guardian. But its survival and the survival of everyone in the building, it all depends on how you install it and care for it from day one. So we're surrounded by this invisible army of machines, all working to keep us safe. They operate in the dark, they're maintained by dedicated people who follow these incredibly strict standards, and they're all waiting for a day they hope will never arrive. The fire pump is their king, a silent guardian, a hero in waiting. So the next time you walk into a tall building, just take a second and think about the beast sleeping in the basement. It's there for you.